Hello friends, welcome back to my channel Chemistry Unplugged. Today we will discuss second organic reagent enamine. It is a very important nucleophile and we will also discuss a reaction related to it is Stork Enamine reaction. It is very important topic for NET, GATE and IIT exams. We will also discuss questions from CSIR Net. The term enamine is formed from two words en plus amine, and it refers to alpha beta unsaturated amine. For example, we have this enamine which has one nitrogen here, and on alpha and beta carbon we have unsaturation. So enamine is alpha beta unsaturated amines. Then we will discuss how these enamines are formed, what are their properties and how they can be used in chemical reactions. So first we will discuss how they are formed. Enamines are formed by aldehydes or ketones and secondary amines. But the aldehyde or ketones must have at least one alpha hydrogen atom, and this reaction is acid catalyzed. And the enamines formed from ketones are more stable than aldehydes, and enamines formed from cyclic secondary amines are more stable than acyclic secondary amines. Now we will see this reaction in little detail. We will later discuss detailed mechanism of this reaction. So we have one aldehyde or ketone here which has one alpha hydrogen. Then we have a secondary amine and this reaction is acid catalyzed. So first is that this lone pair of electron of nitrogen will attack on carbon. In this reaction there is removal of water molecule. So we have one unsaturation here. So it is a alpha beta unsaturated amine, that is enamine. Then example of secondary amines which can be used for in this reaction are pyrrolidine. Pyrrolidine is formed from pyrrole. So it is a pyrrolidine, piperidine and morpholine. We all are familiar with these secondary amines. So they are very frequently used for this reaction. Then we have another example of this reaction, the reaction of cyclohexanone and pyrrolidine. So basically this oxygen and hydrogen is removed and we have one unsaturation on this alpha carbon between this carbon and this carbon, or this carbon. So in the product we have this group is attached here, hydrogen oxygen atom is removed and we have unsaturation here. It is a enamine. So enamine formed from primary amines are not stable, therefore we always use secondary amine. So what will happen if we use a primary amine for enamine formation? Suppose we have this aldehyde or ketone containing one alpha hydrogen, then we react it with this primary amine. Then we have enamine here, but because of the presence of this hydrogen atom, this hydrogen atom can move on this carbon atom and double bond will shift here. So we have imine. So it is a enamine-imine tautomerism. In this tautomerism, the imine formed are more stable than enamine. Therefore, the enamine formed from primary amines are not stable. They will convert into imine. Now let's see the mechanism of this reaction. We have cyclohexanone here and dimethylamine. So first the lone pair of electron of nitrogen will attack on this carbon and this hydrogen will shift to O negative. So we have a intermediate here and this reaction is acid catalyzed. So H plus will attack on this OH to form OH2 plus, and it is a very good leaving group. This lone pair of electron will shift here and we have one alpha hydrogen here. So this bond will shift here. This hydrogen will be removed. this bond will shift here and this double bond will shift to N plus. So we have this as a enamine. Then the enamine are very important nucleophiles. Enamine are good nucleophiles, but the enolates are better nucleophile for alkylation of ketones, but they can be easily synthesized. And for the alkylation of aldehydes, enamines are preferred to enolate. Then how these enamines will act as nucleophile? In this enamine, the lone pair of electron will shift here and this double bond will shift to this carbon atom. So this carbon atom will become negatively charged and act as nucleophile. So the beta carbon of this enamine has carbanionic character. So first we will see alkylation. So what will happen first? This lone pair will shift here and this carbanionic beta carbon will attack on this carbon atom and this Br will be removed. It is a type of SN2 reaction and we have here a iminium salt. It is a neutral salt and then we hydrolyze it and we have this CH2PH group attached on alpha carbon atom of cyclohexanone. So basically this enamine is formed from pyrrolidine and cyclohexanone. Okay, we have seen earlier that this enamine is formed from pyrrolidine and cyclohexanone. So after the alkylation or hydrolysis, finally we have this group attached on the alpha carbon of cyclohexanone. So the net result of this alkylation, this reaction is alkylation at alpha position. Then we see acylation. In the acylation we will use acetyl group. So then we have enamine formed from cyclohexanone and pyrrolidine. So the same reaction will be here. This carbon will attack on this because it is electron deficient. So the pi electron will shift to oxygen atom. It will become negatively charged. In next step, this negative charge will again move here to form pi bond and chlorine will be removed. We again have iminium salt. We hydrolyze it. Then we have acetyl group attached on the alpha carbon of cyclohexanone. All these type of reaction are known as Stork Enamine reaction, alkylation or acylation of ketones using secondary amines, and the reactions are acid catalyzed. We always need a strong alkylating agent for this type of reaction. If we use a simple alkylating agent, then what will happen? The lone pair of electron of nitrogen will attack on the methyl group and we have a quaternary salt of nitrogen here. And upon hydrolysis, we have the cyclohexanone again. We started the reaction with cyclohexanone and in the product we again have cyclohexanone. So there is no alkylation in this reaction. So simple alkylating agents cannot be used. We can use more reactive alkylating agents like benzyl halide, allyl halide, and for the alkylation of reactants, we need a strong base to convert them into nucleophile. In the earlier video, we have discussed about lithium diisopropylamide, which generates lithium enolates. But lithium enolates cannot be used for alkylation of aldehydes because they will undergo self-condensation reactions. So for the ketones, we can use LDA. We can convert them into enolates and then we can do alkylation. But for the aldehydes, enamine formation is a better option. Then what will happen if we use an unsymmetrical ketone? Here we have a symmetrical ketone. In the cyclohexanone, we have alpha hydrogen on both carbon atoms, same alpha hydrogen, and there is no any other group attached here. But if we use a unsymmetrical ketone, like this, then what will happen? The substitution will be favored at less substituted carbon. Okay, so here we are using pyrrolidine again, and we have 2 alpha carbons. So after the reaction, we have 2 type of enamines. One has unsaturation here and other has unsaturation here. So it is the major product and it is the minor. This reaction is favored at less substituted carbon because the enamine formed is stabilized because of the interaction of these pi electrons and the lone pair of electron present on this nitrogen atom, and they should be in one plane for the interaction. And if there is no bulkier group present, they are in the same plane. But for this carbon, there is one methyl group. So the molecule is get twisted and they are no longer planar in nature, coplanar in nature. So they cannot interact with each other. So the enamine formed is not stable. Next we have an example here. In this we are using cyclohexanone, pyrrolidine, 1 alpha beta unsaturated ketone, and this reaction is catalyzed by para-toluene sulfonic acid. We know that enamine formation is acid catalyzed reaction. So first we will use these two. So when the cyclohexanone and pyrrolidine will react, we have seen that this enamine will form. One hydrogen is removed from alpha carbon atom, so double bond will be here. Next reaction is with this alpha beta unsaturated ketone. So what will happen? The lone pair of electron of nitrogen will shift here and this carbon will become anionic in nature, carbanion. It will form carbanion, and this carbanion will act as nucleophile and will attack on this carbon atom, and this electron will shift here. So this carbon is electron deficient, so act as an electrophile. So we have positive charge on nitrogen and negative charge on this carbon. Then we have this hydrogen here. So this negative charge will attack on this proton and this bond will shift here. So this hydrogen will shift here to form CH2, and we again have this double bond here. Then we do hydrolysis and this pyrrolidine group will remove and we again have the initial ketone group here. Okay, after hydrolysis of the enamine, we can remove this whole and this double bond will be removed again. We have the same ketone as we have used in the product. Only the change is that at the alpha carbon atom, we have to attach this substituent. So this type of reaction is known as enamine-Michael addition. When we use alpha beta unsaturated ketone for enamine reaction, it is known as an enamine-Michael addition, and it is very important reaction for the examination point of view. Then how alpha halo esters react with enamine? This is an enamine. We have one enamine here and it is alpha halo ester. This is an alpha carbon and we have one halogen X. Suppose we can use chlorine, bromine or iodine. So we are using term X here. This is an alpha carbon. So it is alpha halo ester group. This nucleophile will attack on this carbon because the halogen atom, because of its electronegativity, will attract the electrons towards it. So this carbon will become positively charged or it will act as electrophile. So we have one iminium salt here. Iminium are the compounds when we have carbon nitrogen double bond. So it is iminium compound. Then we do hydrolysis. So after hydrolysis, as I have said earlier, that this pyrrolidine group will be removed and we have the same ketone group as we have in the reactant. Okay, the only change is that this substituent will attach on the alpha carbon atom, because this enamine is basically formed from cyclohexanone and pyrrolidine. So this is a cyclohexanone group and we have this ester group at alpha carbon atom of it. Next we have this question from CSIR Net. December 2014, and we have 4 options here. So in the first step, we will react ketone with pyrrolidine. So the same reaction, enamine formation will take place, and we will use this alpha carbon atom because it is less substituted. Okay, so the enamine will form here, and then we use this alkene, and this carbon will attack on this carbon atom because after the removal of bromine atom, this carbon will become positively charged and it will act as a electrophile. So this carbon will attach here. Then in the next reaction, we have one alpha hydrogen here also. So this bond will shift here and this bond will shift here to neutralize the positive charge of nitrogen. And here we have double bond due to the shifting of this bond. Then in the next step, the lone pair of electron of nitrogen, this will become another enamine. So the lone pair of electron will shift here and this carbon will act as a nucleophile. So the double bond of this alkene group will shift to this carbon atom because it is attached to CN group and it has more negative I character than ester group. So it will become negatively charged and it will become positively charged. So this nucleophile will attack on this carbon atom. So we have this one ring will form here and this carbon will become negatively charged. Okay, and nitrogen will again positively charged. Then we do hydrolysis, and after the hydrolysis, this pyrrolidine group will removed and H plus will attach to this carbon atom. So this negative charge is also neutralized. We have this ring-like structure. We can also write it down like this. So the option A will be the correct answer. So that's it. I will end my today's video here. Thank you so much for watching my video. Please subscribe my channel if you like the video and share it with your friend and hit the bell icon for future notifications.